Good evening, children. Today we are having this topic, periodic classification of elements. It's a chapter in class 9. So, what is periodic classification of element? Now, for example, when you go to a medicine shop, a medicine shop has different types of medicine. Some of them are painkillers, some are temperature reducing medicines. Some are antacids. There are different types of medicines present in a medicine shop. Now, when you go and ask for a particular medicine, the shopkeeper gives you the medicine in no time. They are very quick in serving the customers. How they are able to find the given medicine so quickly? It is because they have kept the medicine in a proper arrangement. They have kept the medicine, they have classified the medicine into different groups, and that is the reason why it's very easy for them to deliver the medicine which is asked by the customer. In the same way, chemistry is a subject which deals with study of property of elements. Property of elements, when we mean physical property as well as chemical property of elements. Now there are more than 110 elements, and it's not naturally very easy to remember the property of the elements, and also it's very difficult to remember the property of the compounds which these elements are forming. So, different people at different point of time had attempted at classifying elements. One of the method of classification of elements was Dobrynin's triad. Dobrynin's triad. What Dobrynin found is that suppose these three elements, lithium, sodium and potassium, these three elements forms a triad, and these three elements has property very much same, and Dobrynin found that if we consider the atomic masses, lithium atomic mass is 7, sodium atomic mass is 23, potassium atomic mass is 39. It is seen that the atomic mass of the middle element is mean of atomic mass, the first and the third element. You can see 7 plus 39 divided by 2, it comes out to be 23. In this way, Dobrynin could have some triads, okay, but this method naturally was not very successful because he could not classify in this way the other elements. So this method was discarded. Then came as another method called Newland's law of octaves. Newland's law of octaves, and here it is seen that if the elements are arranged in order of increasing atomic mass, it is seen that the 8th element has property very same as the first one. Just like in case of music, the 8th note is same as the first note. 8th note is a repetition of the first note. So if we place the elements in order of increasing atomic mass, say lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine, and after fluorine, the next higher atomic mass element, it is sodium. and sodium is kept here because the property of sodium and lithium is found to be same. So lithium is the first element, sodium is the eighth element. They have property same. Similarly, after sodium it comes magnesium. So if beryllium is the first element, magnesium is the eighth element, beryllium and magnesium has property similar. So this is Newland's law of octet, but it is also not. It was also found to be not so successful because it can be. It is seen that only till calcium this method is applicable. It is not applicable beyond calcium. Then a very good method which got appreciation from all over was Mendeleev's classification of element. Mendeleev's classification of elements, and this classification is based on this law is called Mendeleev's periodic law, which says that the physical and chemical property of elements are periodic function of atomic mass, which means that if elements are arranged in order of increasing atomic mass, there will be a repetition in the property of elements after regular interval. Now, since this video has to be very short, just let me tell you is that this periodic law, statement of periodic law, was found later to be incorrect, and the term atomic mass was replaced by atomic number, and that is the modern periodic law, based on which the modern periodic table is based. So children, this much for now. Hope you like this video. Thank you very much.